Hello viewers, welcome to the Advances in Agriculture Engineering course under the annual refresher program in teaching or in ARPIT. In the previous two modules, we have discussed about the agricultural mechanization as a whole, then the agricultural mechanization in Indian specific context. Now, in this third module, let us discuss the agricultural mechanization situation in the Asia Pacific region. In this module, we will be talking about the global production of major cereals and their growth in their yields. Then we will be discussing the trade-off between higher yields and its land uses, machines use intensity in various Asia Pacific countries, and finally, we will be qualitatively analyzing the agricultural mechanization status in the Asia and the Pacific region. For this module, I would recommend these following references: the ICAR IASRI Agricultural Research Data Book, the Regional Strategy for Sustainable Agricultural Mechanization, the Agricultural Mechanization at a Glance with the case studies of the selected countries in the Asia and Pacific. There are two web references depending on the repeat hoga. There are two web references on crop yield and the CSAM country reports. Let us begin with the agricultural growth in the Asia Pacific countries. First, let us have a look at the global land use for the food production in this world. Let us try to understand in the world where we are staying at. We know that this world is filled with water. About 71% of the total surface area of the earth is covered by oceans, which is remaining 29% as the land area, which is 149 million square kilometer. Now, out of this 149 million square kilometer land area, 71% is habitable land and the rest is used by glaciers, or it is covered by the barren land, which is 28 plus 15 million square kilometer. Now, out of this 71% habitable land, half of which is 51 million square kilometer is under agriculture. 37% is covered by forest and the rest 11% and another 2% are under shrubs, urban buildup and the freshwater resources. Now, let us see how this 50% land, which is 51 million square kilometer, which is used under agriculture, how is it distributed? Out of which 23% is used for the crops, which is nearly 11 million square kilometer, and the rest 40 million square kilometer, which is 77% of the 51 million square kilometer, is used for livestock, meat and dairy production support. So, in order to have a feel of how much exactly land is available for agriculture purposes, we see that this is only a fraction of the entire land availability on this world, which is nearly 11 million square kilometer. Now, if we tend to see that how this land is supporting the global calorie as well as the protein diet intakes. In terms of the global calorie supply, this 23% land, which is 11 million square kilometer, majority of which is 83%, which is coming from the plant based food, which is supported by this tiny fraction of the land as a part of the global space. 18% come from the meat and dairy in terms of the global calorie supply. The situation would slightly change if we classify this 23% land area in terms of the global protein supply, 37% of which is coming from the meat and dairy, whereas 63% is coming from the plant based food. So, this slide emphasis on the importance of agricultural arable land in the global context. Now, if we look at the index of cereal production, yield and the land use, this data is presented during 1961 to 2014, whereas the 1961 values are taken as a reference or 100. There are few things which are clearly obvious from this projection. The population in this world is steadily increasing, so which calls for more food to be produced. Now, in order to produce the food, we have to do agriculture and we have to bank on the agricultural land available. This bottom line shows that almost constant land is available for the agriculture, and there is not much to be added or not much could be added to this horizontal line. So, we have the arable land which cannot be significantly added, if I were to say so. So, in order to meet the food demand of this rising population, we have only few choices left, and the most popular or perhaps the most successful choice was to rise on the productivity. This dark blue trend line shows the cereal yield index, and because of which we are able to so far successfully producing the cereal in the world. The population is nearly 2.5 fold of what we were in 1961. The cereal production has been grown more than 3.5 times in this world, and the gap between the two denotes that the production is not necessarily commensurating to the cereal yield index because of various losses both as at the pre-harvest and the post-harvest. The high yielding varieties and irrigation, they have greatly contributed to the increasing the yields what we have been observing since 1961 to so far, and mechanization would continue to help leverage it further. So, if I were to say that mechanization is a key to our sustenance. Now, let us have a look at the index of cereal production, yield and the land use for the same duration of 1961 to 2014 in Indian context. The situation is not greatly different. We are almost maintaining our land under cereal production because this index is not varying significantly, at least in significance to the rising population. The population growth curve is very steep, and we have neck to neck competition between the production and the cereal yield, and thereby the resulting production index for the cereals. So, we probably do not have much time to lose in order to continue growing on the yields and thereby continue increasing our cereal production to meet the food demand of our countrymates. When we are talking about the cereal yield, there are a number of factors which influence the national average of cereal yield. Of course, these are the average values and they may not be taken in the true sense, but they must be very useful indicator to give us a feel of the direction of agricultural mechanization and the role of agricultural mechanization, what we could play in order to achieve those strategic targets. There are several factors including the topography, the climate, the ecosystem, the technology, the soil constraints which influence the yield values. If we tend to group in the Asia Pacific region, we will see that the relatively low yield. Now, this low is in reference to the world average, which is nearly 3.7 tons per hectare for the cereals. Very low yields are reported for countries like Timor-Leste, Nepal, which is between 2 to 2.5 tons per hectare on an average basis. We have lower yields reported by countries like Pakistan, India, Cambodia and Thailand, between 2.7 to 3 ton per hectare. 3 to 4.2 ton per hectare group of countries include Philippines, Sri Lanka, North Korea, Myanmar, Malaysia, Laos PDR and Bangladesh, whereas higher yields are reported between 4.5 to 5 tons per hectare by Papua New Guinea, Indonesia and Japan. The countries like Vietnam, China and South Korea, they are reporting relatively higher values of average cereal yields between 5.3 to 7 tons per hectare. There are several countries in the Asia Pacific region, especially those which are coming from the lower middle to low income countries. They have to grapple with various constraints that may include the modern technological adoption, poor infrastructure and weak human resource capacity. There is obviously a trade-off between the higher yields and the land use. To put things into a simple perspective, higher the yield will spare the land if we are targeting for the same amount of crop production. So, a ratio which is interestingly described as the land needed per unit of crop production to the crop production index. So, this index of the arable land area which is needed to produce an equivalent aggregate of crop production, it visualizes this trade-off in reference to the land area which was needed back in 1961. This is a combination of agricultural technologies which help us raising in the yield. This keeps the downward pressure on the extent of crop land and it spares the land for nature and for various alternative high productive uses. At the same time, this noticeable shrinkage in the extent of cropland, which is expressed as a function of the crop production index since 1960, it provides encouragement that farmers will continue sparing the land. Now, this graph projects the arable land needed to produce a fixed quantity of crops considering the base of 1 for 1961. Clearly, it is visualized from this graph that today, because of the technological interventions, because of the high yielding varieties, because of increased irrigation facilities, because of better management of our farming and agricultural resources, and because of the agricultural mechanization, we are able to now produce more from the given piece of land, or in other words, for producing the same quantity of crop, we require lesser acreage of land as compared to 1961. The arable land needed to produce a fixed quantity of crop is calculated as the arable land divided by the crop production index or PIN. Now, here the PIN is calculated as the sum of crop commodities minus the crops used for animal feed. This is also weighted by the commodity prices, and this is measured as an index in reference to the 1961, where the value for 1961 is taken as 1. We have reduced on this index relatively from 1961 to recent years because of the combination of agricultural technologies which have helped us increasing on the yield. Globally in 2014, the index value is 0.3, which means that today we require only 30% of the arable land area which was needed to produce the same quantity of food or crops relative to 1961, whereas that spares about 70% of the land for its alternative uses, or in order to utilize that additional 70% of the land to help contribute to the agricultural production. With this thought of 0.3 of the global average, now let us have a look at the arable land needed to produce a fixed quantity of crop once again for year 2014 with specific focus on selected countries. Here is the world average, which is 30% or 0.3. India is well below this world value of 0.3, which is a good news that we are able to spare more land for alternative uses or for enhancing the agricultural production. So, today we are utilizing only 24% of the land in order to produce the same quantity of crops as we utilized in 1961. There are countries like Sri Lanka, which is not able to spare much of its land because the value for this country is 0.89. So, they are almost using the same acreage of land for production of the same quantity of food or crops that they have been producing since 1961. These values alone may not be able to be utilized for making any concrete decision or to make any concrete inferences. These are very indicative. For instance, it shows the country's ability in terms of how to utilize the technology, how to utilize the available potential of land. That ability term is used specifically for the countries like Sri Lanka, Africa and Cambodia. However, we will also notice that countries like Europe or US, they are also not being able to reduce their index better than the world average. Perhaps in those cases, it is about the country's priorities to reduce the pressure on its arable land. In general, however, this index can be utilized to see how effectively the country capitalizes on the technologies in terms of agricultural mechanization and related means. After this discussion, let us have a look at the growth in the yield. What are those trends which are reflected in terms of the yield for these different countries? Let us begin with the yield of wheat, which is also a major crop in Indian context. The world top wheat producers are listed considering the recent figures. China ranks number 1 by producing as high as 134 million metric ton. Followed by India, we have produced 98.51 million metric tons for the given year, followed by Russia, USA, France, Australia, Canada, Pakistan, Ukraine and Germany. Now, for these countries, let us try to see how the average wheat yields in ton per hectare is growing right from 1961 to the year reported 2014. We will see that in the case of France, relatively within the group, the France tops the list in terms of the productivity for the yield for the wheat. It is more than 7 ton per hectare. In terms of the yield, China ranks second within this group of countries we have selected for comparison, which is more than 5 ton per hectare, whereas the India, Canada, US and Pakistan, these countries are reporting the yield values for wheat roughly around 2.8 to 3 tons per hectare, followed by Russia and Australia in terms of the relative yield values. Another thing which we could infer from this graph is the rate of growth or the slope of the lines drawn from 1961 to the recent years. For France, the growth in the wheat yield has increased significantly in the initial years. Now, it is leveling off. For China, it has been steadily increasing, and for India, the growth is steadily increased, but the rate of growth is lesser as compared to China, which can be noticed from the difference in the slope of these two curves. This colorful GIS map reports the average wheat yield in tons per hectare for various countries. The dark blue color represents more than 10 tons per hectare, 9 ton per hectare and so on, whereas the lighter one is nearly 2 tons per hectare or even lower. So, we have countries like China, part of Africa, South Africa and Europe and part of the North America, the wheat yields are very high as compared to the rest of the world. After the growth trends in the yield of wheat, let us discuss the second very important crop of rice, how the yield growth has taken place since 1961 to the recent years. The countries in the world which rank very high in terms of the area cultivated for the rice, according to 2017 statistics, we see that India ranks the number 1. We have spared the highest amount of land area cultivated under rice, which is 43 million hectare, followed by China, where rice has been grown on 30 million hectare of the land, followed by Indonesia 12.16 million hectare, Bangladesh 12 million hectare, Thailand 9.65 million hectare, Vietnam, Myanmar, Philippines, Cambodia and Pakistan to follow. Now, this list was for the rice area cultivated. We will see that ranking has been changed if we talk about the rank in order of rice produced in quantity. If we talk about the quantity of rice produced, China tops the list with 208 million metric tons, followed by India nearly 170 million metric ton, followed by Indonesia, Bangladesh, Vietnam, Thailand, Myanmar, Philippines, Brazil and Japan. So, this difference is due to the differences in the rice yield values for these countries. Let us try to see how the yield values of these selected countries have been increasing since 1961 to the recent years. China and Japan, they top the list. They are reporting nearly 7 tons per hectare of rice yield, followed by Vietnam, which is nearly 6 tons per hectare, Indonesia nearly 5 tons per hectare, followed by Bangladesh 4.5 ton per hectare, Philippines and Myanmar and India, we are reporting nearly 3.6 tons per hectare of rice yield, followed by Cambodia and Thailand. This GIS colorful map shows the average rice yield values for 2014 in tons per hectare. Darker the blue color, higher the rice yield reported relatively. After discussing on the growths in the yield for wheat and rice in different Asia Pacific countries, now let us try to have a look into the agricultural mechanization situation in the Asia Pacific countries. In the Asia Pacific region, the agricultural mechanization has obviously been a powerful tool for achieving the sustainable agricultural production, but at the same time, from the sustainability perspective, the agricultural mechanization debate revolves around two head to head aspects. The first is the feasibility and impact of using higher levels of farm power. This is debated with the impacts of continuous and improper use of technologies on environment and other natural resources. The balance of these two forces will effectively determine the sustainably operating point from the viewpoint of agricultural mechanization. This slide shows the tractor use intensity in units per 1000 hectare of arable land, and we can notice that there are countries which are having very low intensity of tractor uses per 1000 hectare of arable land. which is less than 1 unit, including the countries like Timor Leste, Lao PDR and Bhutan. We have countries like Indonesia, Papua New Guinea, Philippines, Sri Lanka, Cambodia, Myanmar and Pakistan, Nepal and North Korea, which are reporting low intensity between 4 to 30 units of tractors per 1000 hectare of arable land. We have countries including India, Malaysia, Bangladesh and Vietnam, which are between the 35 to 80 units of tractors per 1000 hectare of arable land. They are considered to be having moderate intensity. High intensity, which is corresponding to 150 to 200 units of tractors, that is reported by South Korea, Thailand and China, whereas Japan is a country which reports more than 450 units of tractors per 1000 hectare of arable land is considered to be very highly and intensely mechanized in terms of tractor uses. Similarly, these values can also be calculated for the harvester and thresher uses. Again, for the 1000 hectare of arable land, we can notice that very low intensity, which is less than 1 unit of harvester or thresher, is reported for countries like Sri Lanka and Pakistan. Low intensity between 3 to 5 units is reported for India, Myanmar, Cambodia and Thailand. Countries like China, Philippines, Indonesia and Malaysia, they are having moderate intensity of harvester thresher use intensity between 10 to 20 units. Papua New Guinea, Vietnam, Bangladesh and Nepal, they are having high intensity between 30 to 40 units of harvester threshers. The South Korea is reported to be having very high intensity for harvester uses, which is more than 50 units per 1000 hectare of arable land. There are some key lessons which are learned from agricultural mechanization experiences in Asia during 1960s to 90s. To pay for the investments in mechanical technologies, farmers have to be able to generate income and profit from their production. Due to the high capital cost associated with the tractors, only medium and larger farmers could exclusively utilize them efficiently. Investment on the tractors were profitable only if it could be used for alternative additional off farm uses, that includes haulage more popularly, or when the rental markets are existing nearby. These are not adequate efforts to design implements and machinery which are specific to a particular farming system or for a specific group of farmers. Some review questions arising from this discussion include the global land use for the food production, growth in the cereal yields, world's top producers for wheat and rice, and we have finally discussed about the trade-offs in yield and the land uses. Thank you very much.